There are still a few more parts that we won't get into today, but we'll cover them later. Tonight, Tesla has revealed something surprising about the next stage of their aluminum-ion battery testing. The new leaked details are way beyond anything seen in the industry, and even outshine the earlier aluminum-ion versions we've been talking about for the last few months. Forget the 5-minute fast charging and the 4 million-mile lifespan for a moment. The newest update shows that aluminum-ion could become the safest battery tech in any condition and give your EV the ability to deliver 100% power like a sports car that costs 5 times more. Has your EV ever felt slow when changing lanes on the highway or cost you thousands in maintenance just to avoid potential issues? In this video, we'll break down all the design changes in Tesla's newest aluminum-ion battery and explain exactly how it makes your drive smoother, stronger, and safer than ever. So hit that subscribe button and join the 10,111 members who already understand how Tesla is improving both our drive and our lives. How will Tesla's aluminum-ion battery solve the frustration of slow power response in real-world EVs? Have you ever noticed how your electric car doesn't respond instantly or feels slow when you hit the accelerator to overtake? This is a common slow power delivery issue that most lithium-ion EVs face. The main cause comes from the sluggish movement of lithium ions, a problem that has existed for over 30 years and has never been fully solved by any car maker. While companies focus on improving energy density so the battery can store more electricity, they often ignore discharge efficiency. Discharge efficiency is how fast the battery can release energy. When you press the accelerator hard, the battery needs to discharge energy quickly to give maximum power. But because lithium ions move slowly, this process creates a bottleneck between the electrolyte and the electrode. The lithium ions bump into each other, causing high internal resistance, which heats the battery to around 60–80 degrees within seconds of strong discharge. When that happens, the battery management system steps in to cut power and stop overheating, which makes the car even slower. That's why real-world performance is often far below the numbers written on paper. A car may be advertised with more than 1,000 horsepower or a 0–60 mph time of just over 3 seconds, but in daily use, it feels weaker than expected. It's inconvenient and even risky in moments like sudden acceleration, climbing steep hills, or towing heavy loads. Tesla's new aluminum-ion battery could end this problem completely. To speed up aluminum-ion movement, Tesla engineers are designing a special flux-core cathode built with a nanographene network of tiny nanotubes twisted into spirals. Graphene is arranged into microscopic channels. Unlike traditional lithium-ion cells, where ions move through a single path, Tesla's design creates many parallel routes that allow aluminum ions to travel at the same time without getting blocked. This reduces internal resistance by 17 times compared to lithium. These channels are curved like springs, only 1 to 2 nanometers wide. That design breaks physical limits and triggers a quantum tunneling effect, letting ions pass barriers instantly rather than wasting energy colliding, like speeding through a tunnel instead of climbing over a mountain. Now, aluminum ions can travel at around 500 micrometers per second, about 10 times faster than lithium's 50 micrometers per second. On September 23rd, researchers at Mass University also announced progress with zinc-air batteries, reaching 3,570 charge cycles in 74 days and an ion speed of 200 micrometers per second. Still, Tesla's aluminum ions are faster. They discharge nearly 10% the speed of light and can deliver peak current in milliseconds when needed. With a continuous discharge rate of 375 watts per cell, 13 times higher than many lithium cells. Plus, aluminum has 3 times better thermal conductivity than lithium, so when it's discharged at high power, the heat spreads evenly throughout the pack. The battery temperature stays below 50 degrees even under stress, meaning the management system doesn't have to interfere or lower the voltage when the car is demanding full power. The everyday benefits are huge. Under high power, aluminum batteries can instantly reach full capacity, unlike lithium batteries that reach only about 60% due to slower discharge limits. The current Tesla Model Y with lithium batteries accelerates from 0 to 60 mph in about 7 seconds in the standard version, but with aluminum batteries it can drop to around 4 seconds. In internal testing, a Model 2 prototype with aluminum-ion cells hit 0 to 60 mph in 3.7 seconds with only a single rear motor. That means it feels like driving a premium sports car, confident and powerful when overtaking on the highway without hesitation. Aluminum cells also maintain power under heavy loads. They keep strong traction through mud or steep climbs without losing torque, even when fully loaded with passengers or cargo. For example, in the Cybertruck tests with lithium batteries pulling 5,000 kilos uphill, the speed dropped from 100 km/h to 70 km/h after less than 2 minutes due to overheating. But with aluminum batteries in internal tests, the truck maintained full power for over 9 minutes without pressure loss, keeping 100 km/h throughout the climb while staying under 47°weak C. Have you ever been frustrated by your EV losing power halfway up a hill or lagging behind when overtaking? This is exactly what Elon Musk is preparing behind the scenes. Tesla's secret weapon to destroy the old limits of lithium power. Type aluminum power in the comments if you're ready for the next leap in EV performance. And if you're curious about Tesla's other new battery tech, check out our videos on aluminum, solid-state, sodium, and other future cells to see just how far Tesla is pushing energy innovation. Now, why are Tesla's aluminum-ion batteries almost immune to environmental damage, making them the safest battery pack ever? Current lithium-ion batteries show weaknesses fast when conditions get rough. At temperatures below 10°C, cells freeze and lose energy. Above 50°C in floods or after strong impacts, they can crack, catch fire, or even explode. No one wants to risk that. A car should make you feel safe, especially on long trips through rain, snow, or desert heat. It should protect you and your family, not be a hidden danger. Tesla's next phase aluminum-ion design changes that by building safety from the outside in, making it nearly immune to all environmental effects. It starts with a stronger protective shell. Using the new Gigafactory production methods, aluminum-ion packs are now built as structural batteries, cast in one solid piece using the 16,000-ton GigaPress technology. Instead of a collection of small modules bolted together, the pack is a single weld-free block fully integrated into the car's frame. The material used is high-grade 7075 T6, aluminum alloy with a tensile strength of 1,200 megapascals, about 5 times stronger than the 250 megapascals of conventional steel used in lithium packs. That means the battery can take heavy impacts without deforming or damaging internal parts. Outside the aluminum shell, Tesla adds a polyceramic layer similar to materials used in military-grade armor. In Fremont Labs, they've upgraded this layer with nanotech, making it 30% better at absorbing and spreading out impact force than the steel protection used in lithium batteries. The coating can resist collisions up to 200 km/h without cracking, and if it's punctured, the dynamic polymer structure heals 90% of the damage in half a second, instantly stopping any leaks. Thanks to excellent insulation, the polyceramic shell also keeps internal temperatures below 45° even when it's 60° outside and prevents freezing at temperatures as low as 20°C. It's also highly resistant to corrosion from mud, salt, or floodwater. But what really makes it safe is inside the cell itself. Unlike lithium batteries, which use a flammable liquid electrolyte that can release gas and ignite around 90°C, aluminum batteries use a non-flammable, non-volatile ionic gel that stays stable up to 300°C, completely preventing thermal runaway. Aluminum ions are also far less reactive than lithium. They don't react with air or form dendrites that cause short circuits. The aluminum graphene electrode spreads ions evenly, avoiding hot spots that often appear in lithium cells, allowing ultra-fast charging even at 20°C while keeping the battery below 55°C. Tesla's internal tests show that these aluminum batteries reduce the risk of internal fire or explosion to below 0.001%, compared to up to 1% in lithium packs under extreme stress. In the end, Tesla's aluminum-ion battery rewrites the rules of safety, performance, and durability for electric vehicles. Safer under every condition, tougher against the elements, and strong enough to deliver sports car-level performance whenever you need it. Would you want to see this technology hit the roads in 2026, or maybe even inside your next EV? Share your thoughts in the comments below.